Hello, this is Dr. Eddie Morgan over at Clovis East High School. Let's get ready to look at our Unit 3 review in order to get ready for our test that's coming up. Problem 1 asks us to find the slope of the line that passes through these 2 points, minus 5, 6 and 3, 7. Remember, the slope formula is the difference between the y points over the difference between the x points, sometimes called the rise over the run if you see it on a graph. And it's written this way: the y in the second point, that's not a square, that's down below, minus the y in the first point, divided by the x in the second point over subtracting the x in the first point. If I wrote them up here, this would be our first point, so this would be x1, y1, and this would be x2, y2. So we just plug those in. So our slope here is going to equal, sometimes I set them this way so I can see them easier. I'll put minus 5, 6, and 3, 7. And since it's the second one minus the first one, I'll go 7 minus 6. Okay? So on top I have 7 minus 6. And then down below, or above, 3 minus 5. Now be careful of your negative signs here. 3 subtract, but I'm subtracting negative 5. Okay? Now remember, 7 minus 6 is 1, but 3 minus 5 becomes 3 plus 5. So our actual answer is 1 over 8 is the slope. If I were graphing it, it means from one point I would go up 1, and then I'd go over 8. And that would be a slope of that kind of line. Problem 2 asks us to write the equation in the point slope form for a line that has a slope of 5 and goes through the point negative 7, negative 11. Now remember, the point slope form looks like this: y minus y in one point equals the slope times x minus x in one point. So here's our slope, and here's our x1, y1. So this question is simply a matter of plugging in those two things and maybe doing a little simplifying. So this is going to be y minus, and then my y1 here is minus 11, equals the slope, which is minus 5, times x minus, and then again minus 7. Something tough about this one is making sure we keep our negatives straight. Y minus a negative 11 is y plus 11, equals minus 5, times x minus a negative 7 becomes x plus 7. And since they asked us to leave it in that form, that's our answer. Problem 3 asks us to change the equation in problem 2 to the slope-intercept form. Remember, we ended problem 2 with an equation that looked like this: y plus 11 equal minus 5 times x plus 7. And we want to get it in the slope-intercept form, which looks like this: y equals mx plus b. So the key thing is we want to solve this so that x here is by itself, and we have one x term over here. So the first thing we're going to do is distribute on this side to get rid of the parentheses. So we end up here with y plus 11 equals minus 5x minus 5 times plus 7 is minus 35. Now all we have to do, see, we have an mx and a term, but we have an extra one over here, so we need to undo the plus 11 by subtracting 11 from both sides, and we'll arrive at y equals minus 5x minus 46. And there's the same equation in slope-intercept form. Problem 4 asks us to find the x and the y-intercepts for this equation. Now remember, when you find the x-intercept, That's where it intercepts the x-axis, and where the x-axis is where y equals 0. To find the y-intercept, if you look at the axis, all along the y-axis, it's x equals 0. So to find these, we simply need to plug in x equals 0 or y equals 0 to find it. So let's start with the x-intercept. So to do that, the x-intercept is where y equals 0. So I'm going to plug in my equation, minus 5x plus 10, but now I'm going to put in for y equals 0. And now that goes away to 0. And so I simply have minus 5x equals minus 30. So undo the multiply by negative 5 by dividing by negative 5. And I find out that x equals positive 6. And so that's my x-intercept. Or I could write the point 6, 0. Now in a similar way to find the y-intercept, this is where x equals 0. So I write the same equation, but this time minus 5, and I make x be 0. Plus 10y equals minus 30. So again, that times 0 is 0. So I'm left with 10y equals minus 30. So we're going to undo the 10 times y by dividing both sides by 10. That goes to 1. So I'm left with y equals minus 3. That's my y-intercept, or if I want to write the point is 0 minus 3. So those are my two x and y intercepts. If I were graphing this, you can see a quick graph. My x-intercept would be 1, 2, 3, 4, 5, 6 right there. My y-intercept would be minus 3, 1, 2, 3 down there. And my graph would look something like that. Problem 5 asks me to find the y-intercept for this absolute value equation. Remember again, the y-intercept is where x equals 0. So I take this equation and I put in x equals 0. So I get y equals the absolute value of 0 minus 3. So I end up with y equals the absolute value of minus 3. Remember, absolute value is how far is the number inside the brackets away from 0. Always a positive number. So my answer is y equals 3. That's my y-intercept, or the point 0, 3. Okay. Now, if somebody asks you to find the x-intercept, and that's not the question here, here you would have to say, okay, let's let y equals 0, and I would end up having 0 equal absolute value of x minus 3. Well, for this to be the absolute value to be 0, it has to be 0. So I ask the question, 0 equals x minus 3. So I would have to add 3 to both sides to undo that, and I would get that 3 equals x, and that would be my x-intercept. Okay. If we were graphing this, you can see it'd be kind of tough to see it. But the y-intercept is at 1, 2, 3, and the x-intercept is at 1, 2, 3 here. And because it's not a straight line, it's not as obvious, but this is the absolute value function that looks like this. Problem 6 asks us to look at the next two lines and answer whether they are parallel, perpendicular, or neither. This is simply a matter of looking at the slopes. All right. If the slopes are the same, they're equal, that would imply the lines are parallel. If the slopes are opposite reciprocals, see if I can write correctly. then that means that they are perpendicular. And obviously, if they're neither of them, then it's neither. Opposite reciprocals is if I have a number like 2/3, the opposite of plus 2/3 is minus 2/3. The reciprocal is 3/2. So those would be opposite reciprocals. So let's look at ours. First of all, the equation 4x minus 5y equals 6. Easiest way to find the slope is to put it in the slope-intercept form, which means solve for y. So let's get the y all by itself. Let's subtract 4x from both sides. We get minus 5y equals minus 4x plus 6, putting it in that form. And now we're going to get this undone over on the other side. Undo the minus 5 by multiply by minus 5 by dividing by minus 5. Remember, you divide everything on both sides. So that becomes 1. And our equation is y equals negative divided by negative is positive is 4/5x minus 6/5. So looking right there, we can see that the slope equals 4/5. All right? Now let's go to the next one. We have y minus 3 equals 4/5 times x plus 2. This is in the slope, the point slope form, so we can immediately see, here's our slope right here. So the slope is 4/5. Notice they're the same, so our answer is parallel. These two lines have the same slope, so that means they are parallel lines. Problem 7 asks, which of the following is a solution to this equation? Now, the way to find a solution is if you put the number, the x and the y, into the equation, and you simplify it and you get an identity, then you know it's true. If you get something that's not identical, then it's not true. However, to start off with, I noticed because this is in the slope-intercept form, my y-intercept is -3. Okay, so I don't need to solve that one. That's the equation. That's going to be the point 0 minus 3. So I know, for example, that this one is going to be a solution right there. Okay, you can see 3/5 times 0 is 0 minus 3, and that would equal minus 3. So we have one solution. So we just got to figure out the others. So let's start with A, and we're simply going to plug in what we have here. I'm going to do the one side and simplify it and see. I'm going to put x in and then see if I get f of x. So I have 3/5 times 10 minus 3. Okay. So this is going to be, imagine make that into a fraction so we can multiply it. So I have 30 divided by 5 minus 3. So 30 divided by 5 is 6. 6 minus 3 is 3. So this would be the point, if I put in 10, this is actually would be the point 10, 3. Okay, so that equation doesn't work. However, notice that right there, that worked there, so we've actually discovered the other point. 10, 3 is another point that works. So A doesn't work, but it exposed to us, and in other words, 3 is not the one we got up there, but it does kind of show us that works out for D. So let's try B, which I'm guessing is not going to work because we already have a 0 point. But just to show you how this worked, 3/5 times 0 minus 3. Notice that's going to be 0, so I get 0 minus 3 or minus 3, and you see that doesn't work. But then there's our point, 0 minus 3, which is the other point we selected. So C and D in this case are our answers. When you plug them in, you get an identity. And notice this is not +3, which is what B was showing us there. Problem 8 states that the following table represents a linear function showing the distance Bob has traveled. Now, one thing about a linear function is that the slope and the average rate of change is going to be the same no matter what points you pick. So when it says to find a slope, I'm going to pick I'm going to call it the delta y, the change in y over the change in x. Okay, so we're showing this in terms of miles in terms of hours. So this is our X and this is our Y. Very important that we understand which is the X and which is the Y. So the miles Bob travels depends upon how long he travels. So X is our independent. And Y is our dependent. You gotta watch this because you'll have one like this on the test, and if you do it upside down, you'll get it wrong. So the miles depend upon how many hours. Now to find the slope, it doesn't matter which ones we choose. Okay, so I'm going to choose the last two, go over the whole thing, and so I'm going to go from here. So I have 315 minus 45 over 7 minus 1. Okay, so 315 over minus 45, do a little quick calculation over here. 5 minus 5 is 0. Borrow 1 from there. 11 minus 4 is 7. 270 divided by 6. So let's do 6 into 270. 6 goes into that 4 times. 4 times 6 is 24. Remainder 3. Bring down the 1. 6 goes into that 5 times. So our answer is 45. That's the slope. Or you could say 45 miles per hour. Right? So that's our slope, 45 miles per hour. Now, to find the average rate of change between 3 and 7, we know the answer is going to be 45. But just to show us how it works, we're going to go between 3 and 7. So here we're going to do 315. This time we're simply going to do our change in Y over our change in X is going to be 315 minus 135, and up here it's going to be 7 minus 3. So again, let's do a little quick calculation. 315 minus 135, 5 minus 5 is 0. Borrow the 2, 11 minus 3 is 8, 180. Divided by 7 minus 3 is 4. Okay, so 4 into 180. 4 goes into that 4 times, 16 with 2 left over. And guess what? We got 45 miles per hour again. Okay, so our average rate of change and our slope are identical. And that's always true in a linear function. Problem 9 is almost exactly like problem 8. They just changed the table around. Here's our X, and here's our Y, or f of x. So we want to find the average rate of change. We'll pick 2 points. I'm going to pick here to begin with 3 and 4. 3 and 4 and negative 13, negative 8. And remember, the average rate of change is the change in Y over the change in X. Or if you write it this way, this Y in the second point minus the Y in the first point, X in the second point minus X in the first point. So when we get up here, we're going to have negative 8 minus 13. Be careful here. Negative 8 subtract minus 13. We're looking for how far, what does it change going from the first one to the second one? And over here we have 4 minus 3. So negative 8 minus 13 is negative 8 plus 13 over 4 minus 3 is 1. So 13 minus 8 is going to be simply 5. 5 over 1, or 5. So that's our rate of change. Every time x goes up 1, every time x goes up 1, y goes up 5. See this? Plus 1, plus 5. Notice here if you did it again, plus 1, and this goes up plus 5. Now it asks to find the slope from x3 to x1. Okay, so here in this case, we're looking specifically between these 2 points. So once again, my slope is my change in y over my change in x. So it's going to be my change in y is minus 3 minus a negative 13 over 5 minus 3. So here again, this is minus 3 plus 13. 5 minus 3 is 2. So this is going to be 10 over 2 which equals 5 over 1, or 5. And as we expected, because it's a linear function, the slope and the average rate of change are going to be the same no matter what point you pick. Problem 10 gives us a function here and asks us to graph it. Now notice that it is in the point slope form, y equals mx plus b, and when you have it in that form, this is your slope and this is your y-intercept. Okay? So as I write this equation down here, f of x equals minus 3/4 x plus 3, I can see there's my slope. My slope is minus 3 over 4, and my y-intercept is 3, or the point 0, 3. So let's just graph that. Start by using your y-intercept, the point 0, 3, go to the origin and go up 3. 1, 2, 3. Our graph goes to that point. It has a slope of minus 3 over 4. So that means from this point, if I go down 3, 1, 2, 3, and then over 4, my second point is going to be right there. You can imagine the little triangle here. Down 3 over 4. That's what that slope means. And so now, between those 2 points, you can draw your line. If I wanted to, I could go back 4 here. 1, 2, 3, 4, 1, 2, 3. Just because I don't have an eraser here. I mean a ruler here. Oops, I only went up 2. That'll get me off. So then my line's going to go through that point like that. And that's our graph. Use the y-intercept to get your first point. Use your slope to get your second point. And then draw the line. Problem 12 asks us to write the equation of a line that passes through this point and is perpendicular to this line. And they want it in slope-intercept form. First thing to remember is a perpendicular line implies that the slopes are opposite reciprocals. Okay? So when I look at this line y equals 4x plus 3, I immediately notice, oh, the slope is 4. So if that's 4, what's the slope of the perpendicular? Well, it's the opposite. So first of all, it's the opposite. So what's the opposite of 4 would be minus, plus 4 minus, and then what's the reciprocal? If I call this plus 4 over 1, the opposite reciprocal is going to be negative 1 over 4. Okay? So that's the slope we're going to use. And now we can go back to our point slope formula to start off with. Remember, the point slope formula says y minus a point y1 is m times x minus x1. So we can plug these in. We get y minus, and our y here is 20, equals, our slope is negative 1/4 times x minus, and remember, this is our x1, y1 up here, minus 8. Okay? Now, if they set it, and let's simplify that, so we get y minus 20 equals minus 1/4 times x plus 8. If they just said any equation, that would be our answer. But they want it in this form, and remember, this form, slope-intercept form, is the y equal mx plus b. So as we've done before, we just have to realize, first thing we're going to do is distribute the slope across here to get rid of our parentheses. So we end up with y minus 20 equals negative 1/4 x, and then minus, and just a note down here in calculating this, if you have trouble with fractions, minus 1/4 times 8, change the 8 to a fraction, and now you multiply the numerators, so you get minus 8 over positive 4, or negative 2. So this is going to be minus 1/4 x minus 2. Now we're almost there. We need to undo the subtract 20 on this side by adding 20. And our equation ends up being y equals minus 1/4 x plus 18. And that's the answer. This is the perpendicular line through this equation that goes to the point minus 820. Problem 13 asks us to take this equation and change it to the slope-intercept form. Remember, the slope-intercept form is y equals mx plus b. So let's do that first. 3x minus 9y equals 18. And I want to solve for y. So I'm going to undo the 3x by subtracting 3x from both sides. So I get minus 9y equals minus 3x plus 18. And then we're going to divide each side by negative 9. That becomes 1. Negative 9, negative 9. So finally our answer becomes y equals, negative divided by negative is positive, becomes 1/3 x. 18 divided by minus 9 is 2. And so there's our equation in slope-intercept form. Now we can solve it two ways. We can graph it two ways. If we use this equation, we know that our y-intercept is 2. So y down 2, there it is, and it has a slope of 1/3, which means you go up 1 and over 3. And there's the point. The other way you could do it is you could look here and say, oh, my x-intercept, when y is 0, means 3x equals 18, so x equals 6, or the point 6, 0. And that would be, notice here, that would be this point here, 6, 0. Which you could have also gotten by going up 1 and over 3. Just confirming that the x and y-intercept, either way, would be useful to find this equation. And so now we can draw the line. By the way, I can go backwards here with my slope, down 1, back 3, down 1, back 3, just if I want to draw easily without a ruler. And there's my graph, even with it. And I still did draw it very straight. You use a ruler. Problem 14 gives us this equation and asks us to find the x and y intercepts and then use them to graph it. So let's start with the x-intercept. Remember, the x-intercept, where does it cross the x-axis here? All along the x-axis here, what's true is that y equals 0. So I simply have to plug in y equals 0 into my equation. So I have 2x plus 4 times 0 equals 12. Well, that's 0, so I end up with 2x equals 12, or undo the multiply by 2, and I see that x equals 6, or the point 6, 0. Now the same thing for the y-intercept, where in this case, all along the y-axis here, x is 0. All right. Get that a little cleaner for you. So in this case, we're going to substitute x equals 0. And this time you see that goes to 0, so I simply have 4y equals 12. So we undo the 4 times y by dividing by 4. That's 1. And we get y equals 3, or the point where x is 0, 3. Now it's simple to graph. My x-intercept is 6, 0, so from here I count over 1, 2, 3, 4, 5, 6. And my y-intercept is 0, 3. That's going to 0 up 3. And then we just simply connect the dots. All right? Again, very bad drawing by me. Problem 15 is actually a repeat of problem 2 on this review, which probably indicates to you that you're going to get this question once in the multiple choice section and then later on in the constructive response section. Remember that the point slope form says that y minus the first y in one point equals the slope times x minus the x in one point. And notice here, here's our slope, and here is our x1, y1. So all we have to do is plug those in, and we get y minus, and our y1 is -1, so just be careful here. And then that equals our slope, and our slope was -3, times x minus, and here we have 2. So the only thing we need to change is y minus -1 becomes y plus 1 equals -3 times x minus 2. And since it told us to leave it in the point slope form, we can leave it just like that, and that's our answer. Now 16 is an interesting problem. There is a hard way and an easy way to work this problem. Actually, they're both fairly easy. One way is if you don't remember how this absolute value functions and translates, you could always just set up a table, okay? And you can do that for any graph you're ever doing. I have x, and then I have absolute value of x plus 1, and then what's my resulting going to be for y. So let's take some numbers around 0. So like I could put in -2. What's the absolute value of -2 plus 1? That's 2 plus 1 is 3. Remember, the absolute value of -2 is 2. Put in -1. The absolute value of -1 is 1. 1 plus 1 is 2. Put in 0. The absolute value of 0 is 0 plus 1 is 1. And so you end up with 1 is going to be absolute value of 1 plus 1 is 2. Notice now my graph starts going, it was going down 3, 2, 1. Now it's going back up. And 2, the absolute value of 2 is 2 plus 1 is 3. And then I could plot these points over here, and I would get the equation. I'm going to end up here 0, 1, and there is my graph going right up through those points there, 45-degree angle through those points like that. All right, the other easier way would have viewed to have remembered that the equation simply y equals minus absolute value of x always starts here and looks like this. And then to realize, oh, if I'm going to do y equals absolute value of x plus 1, all I had to do was take everything and move it up 1. So I could have started with this one and said, oh, I'm going to draw the same graph, but I'm going to move it up to this point here and then draw my V. All right? So you can always do the table, or if you're thinking about it, you can just draw the V here. Now remember, it goes up 1, 1, 1. Okay, so don't just get a point there and draw a V. You know, it's a very specific V. It's not just, you know, it's not, you can't just go, oh, it's a V, so I'm going to draw one that looks like this, or I'm going to draw one that looks like this. It's got to go up by up 1 over 1, up 1 over 1 to get the exact point there. Now, number 17, as we go to graph this line, we remember that if we have an add or subtract inside the brackets, it's either going to go left or right. And the way I always ask it is because it's going to go left or right, I want to know when y is 0, what's x? So notice if I put 0 in here for x plus 1, I realize for this to be 0, it has to be 0 inside. So that means 0 equals x plus 1, or subtracting 1 from both sides, I find out that x equal minus 1, minus 1, 0. My thing is going to shift to the left. It's going to be this point here. Now that should be enough for me to tell me that my graph is going to be, again, up 1 over 1, up 1 over 1, and notice right through those corners there, carefully through those corners. All right, that's going to be my graph. If I don't remember that, then I go back to setting up my table and saying x, okay, absolute value of x plus 1, okay, and y, and I'll pick some points here like I know there, so I'm going to go like minus 3. So the absolute value of minus 3 plus 1, minus 3 plus 1 is minus 2. The absolute value is 2. Minus 2, the absolute value of minus 2 plus 1. Minus 2 plus 1 is negative 1, but the absolute value is 1. Minus 1, as we've seen, minus 1 plus 1 is 0. And then we get 0. 0 plus 1 is 1. And 1. 1 plus 1 is 2. So we get the same. These are the same points you notice here. Negative 3, 2. Negative 2, 1. Negative 1, 0. 0, 1, and 1, 2. So remember, if you get stuck on these problems on the test, just go make a table and see where they're at. Or you can begin to remember, oh, if I have the absolute value of x plus a number, then it's just going to go up b. All right? If I have the absolute value plus b inside, it's going to go left b. All right? And obviously, if it's minus b, it'll go down, and minus b will go to the right. So there's two different ways to graph that. Problem 18 states that the height, h, in inches of a tree is given by this equation, h equals 2m, where m is the number of months. What's the y-intercept and what does it represent? Well, this is in the slope-intercept form. So if you compare here, h equals 2m plus 7, you can see that this is the slope-intercept right here. So the slope-intercept is 7. Or in this case, it's going to be my y-intercept, my y-intercept is 7 inches. The slope is 2, which means that it grows 2 inches per month. All right? So if I have a tree and the formula says this thing grows 2 inches a month, and it says that y-intercept is 7, it means that this is the beginning. 7 is the y-intercept is the beginning height of the tree, i.e., in other words, at 0 months, the tree is 7 inches tall. Now you're thinking, how can something start off at 7? Well, probably this is an indicator that this may be a nursery and they buy seedlings. So somebody's grown the tree from a little seed, and usually they're shipped to the nursery, and at the point at which the nursery gets it, they start measuring it. So most of their seedlings come in at about 7 inches to start. And that's how you can get this kind of equation. Problem 19 is a very important problem in this review because it's one of the problems on the test that, while it's not that difficult, has many parts, and sometimes students get frustrated and they quit on the problem too early and lose some relatively easy points. So just make sure you realize that every point, this problem is worth about 8 points. That's like 4 multiple choice questions. So don't give up on it. So first of all, it says a club sold a hamburgers X for $3. And hot dogs Y for $2.50, and they raised $2.40. So first thing they want us to do is write an equation. Okay, so we notice we get $3 for a hot dog, so that's going to be 3 times X. If I sell 2 hot dogs, hamburgers, I get $6, 3 I get 9, etc. I get $2.50 for the hot dogs, so that's plus $2.50 times Y, and it added up to $2.40. So that's my equation. So the first step was to write the equation. Second was we're going to graph it. Okay, we're going to graph, label, and find some other points. So notice here, first thing I'm going to do is find my x-intercept. That's the easiest way to graph this one. Remember, the x-intercept is where y equals 0. So in this case, I'm going to have 3x plus 250 times 0 is going to be 0. So I end up with 3x equals 40. Which simply implies that my x-intercept is 240 divided by 3, which is 80. Okay, or that could be the point, 80, 0. Now to find my y-intercept, that's the place where x equals 0. So in this case, 3 times x is 0, so I'm just left with 2.5y equals 240. Which implies that y equals 240 divided by 2.5, which with my calculator tells me it's 96. Now at this point, something simple to do, but students sometimes give up on it. I need to label my graph. First of all, I got my axis, all going to be positive, so I'm just going to have the first quadrant. So here's my x, and here's my y. So down below here, my x is my hamburgers. So I got to put in my hamburgers. And up here are my hot dogs. Now on the bottom here, it has to go to 80. So if I count here, obviously this isn't going to go 80 by ones, but I notice if I go by fives, it'd be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Not enough. So let's go by tens. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So that'll fit in there. And for here we go 96, so the same thing can work up here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right. Now we can graph. Notice our x-intercept is 80, so my first point is the point 80, 0. So it's going to come down here. What this point means is if the only thing I sold was hamburgers, then to get $240, I sold 80 hamburgers. Same time on the hot dog side, the x-intercept is 96, so we come up here to 90, halfway between and a little more, 96. And this means if the only thing I sold was hot dogs, that I sold 96 of them and 0 hot dogs. So now my line can be written, and on the test you want to make sure you do it well with a ruler, is there's the graph of the lines. Now, it's very difficult to actually pick out some points, although you can see a couple here that maybe might be a good hand. But one way to get this accurately is to say, what's the slope? Well, notice between these 2 points, the change in y over the change in x, just using the intercept, from the top it went down 96 over 80. Okay? Now notice that if I divide that by 8, I see 8 goes into both of these. I get 12 over 10, or I could say that's 6 over 5. I can easily find points by using my slope going down. In other words, this is going down minus 12, minus 6. In other words, if from 96 I go down 12 and over 10, I'll get that point there. Notice I'm using my hamburgers of 10. So 96 minus 12, so when I have 10 hamburgers, 96 minus 12 is going to be 84. Now if I go to the next place here, okay, here when I get 20 hamburgers, 86 minus 12 is going to be 72. So notice how I'm using the slope to find the points just in case my graph's not accurate. So here I'm at 30 hamburgers, and 72 minus 12 is 60. You can see my line wiggled a little bit. This actually should have been right about there for real. Okay, if I had drawn a good straight line. And now I get down here and we hit the point 40. And 60 minus 12 is 48. And now go to the next to 50 hamburgers. 48 minus 12 is going to be 36. And then go to 60 hamburgers. Notice I'm going up 10, and so that means this goes down 12. 36 minus 12 is 24 hamburgers. And then up 10 to 70 hamburgers, and 24 minus 12 is 12. And if we did it right, up to 80, and then 12 minus 12 is 0, and we're back to our y-intercepts. So notice I've picked out 1, 2, 3, 4, 5, 6, 7 other points that are possible. Any of those points would answer the question in 3 combinations. But here's a critical point. I mean, my slope helped me find the points easily, mathematically, although if you draw your lines really good, you might be able to see it. But sometimes you'll look at a point and you think that's close and it's not. So whatever point you pick, make sure it works. For example, let me just pick a point. I'm going to pick this point here and say, I think that's a point. Well, let's figure it out. Let's take my equation and we'll put in here, okay, 3 times, what's the x? I have an x of 40 plus 2.5 times my y is 48. And let's see, does that actually equal 240? If it doesn't, then that's not a point. But if it does, then I know that's a good point. So 3 times 40 is 120. And 2.5 times 48 is also 120. So you notice here, we're asking the question. And sure enough, it does. So because of that, I know that that's a valid point. So just make sure whatever points you pick to answer on the test, and I think it only asks for 1 more. It asks for 3 points, but you have 2. You already have your intercepts as 2 of the problems. And so make sure it fits in there. All right? Problem 20 is kind of a vocabulary question that actually goes back to last unit. The question is each of these a linear function, and explain? Well, we've been looking at linear functions, and we've seen them in a couple of forms. We've seen them in the slope-intercept form. We've seen them in the point-slope form. And we've seen them in the standard form. So if we see anything in these forms, we know they're linear. So for example, here is slope-intercept, so that's one. Here is the standard form. When I look at the other ones, though, notice this x cubed. So that is not linear. Okay? Something we haven't really covered, but that's a cubic function. Cubic meaning x cubed. This one here, notice we have the absolute value bracket. So that's absolute value. So that is not either. So the yeses are B and D. Our last problem asks us to find the equation that passes through these two lines, 3, 5, and 6, 13, and write it in the slope-intercept form. So let's begin by finding our slope. Remember, our slope is y2 minus y1 over x2 minus x1, where you remember that this is x1, y1, the x in the first point, the y in the second point, the x in the second point, and the y in the second point. So I'm simply going to take 13 minus 5, the change in y, over the change in x, 6 minus 3, and my slope is 13 minus 5 is 8 over 3. So that's my slope. Okay. Now, I can't go to the slope-intercept form because I don't know the intercept. So my first step is going to be to go to the point-slope form. Okay. So y minus y1 equals slope times x minus x1. And so I'm going to use here my slope, 8 over 3, and my y, I'm going to pick one of these points. Well, I'm going to pick the smaller point. So I'm going to put y minus 5 equals 8 over 3 times x minus 3. And now all we have to do is go into the slope-intercept form, which is y equal mx plus b. So we're going to distribute here. So we get y minus 5 equals 8/3 x, and then 8/3 times negative 3. Notice if you struggle with this, 8/3 times minus 3, change that to a fraction over 1, multiply across, negative 24 on top, 3 on the bottom, so that is a negative 8. So this is going to be minus 8. And now undo the subtract 5 by adding 5. And we get y equals 8/3 x minus 3. And that's the answer. All right, I hope this helps you. It should, if you go through these problems carefully, you'll find the test is very easy.